A very good afternoon to you all. Respected Dean HBNI, Professor A.K. Tyagi, today's speaker, Dr. Kruti Halankar, R&D Product Leader of Mercedes Bank and Automotive Cell Company, Mainz, Germany. Associate Deans and Assistant Deans of HBNI, other officials and staff of HBNI, Dean Academy of HBNI and HBNI faculties and students, all offline and online participants. It is my absolute pleasure to welcome you all in this special session organized by HBNI as a part of the placement initiative for HBNI students. A very warm welcome to today's speaker, Dr. Kruti Halankar, R&D Product Leader, Mercedes-Benz, an automotive cell company, Mainz, Germany, who has kindly agreed to give a webinar in spite of her very busy schedule. I will invite Professor A.K. Tyagi, Dean HBNI, to give the opening remarks.
Thanks, Professor Datta. Dear colleagues, online and offline, Dr. Kruti Halankar, Speaker of the Day, warm welcome to you all. After one does PhD, there are several avenues. One can go to academics, one can also go for teaching, one can join national labs, one can have own enterprise. That also is highly encouraged. One can become employer instead of employee. One difficult route which not many people adopt is switching over to industry. Usually it is observed, those who are in academics, they continue in academics, and those who are in industry, they continue in industry because of comfort zone and other reasons also. Here we have a person, Dr. Kruti Halankar, who after spending close to 6 or 7 years in academics, very comfortably, seamlessly switched over to industry. Many of you may not know, she is my own PhD student. I remember way back in 2016, a very young student who was looking like a 12th class student entered my room and introduced herself. Sir, I am Kruti, not doctor at that time. I would like to discuss something with you. I could realize because I had a vacancy in my group. Not actually a vacancy, I had submitted a proposal for consideration. So she knew that I am one of the guides who have submitted the proposal. We discussed for about 10 to 15 minutes. Then of course I sent her to discuss with other colleagues, Balaji in particular. And that time we had a project on lithium-ion battery developments. Out of a good number of projects in chemical sciences that year, she selected our project. And that's how she became my PhD student. She was 33rd student of mine to complete. She has gone a long way. Students also I can classify in different categories. Students who work hard. Student who work smart. Third category, let us not discuss openly. Then there is one more category which is somewhat rare. The students who work hard and smart, both components. They are hardworking as well as they have enough smart component also. Once you have both the components, working hard component, working smart component, you become Kruti Halankar. She has done remarkably well. After her PhD tenure was over, she worked in HBNI also for 4 months as project assistant. There was a time when I was working on a book with then Vice Chancellor, Professor P.R. Vasudev Rao. And this title of the book was Atomic Energy in India, Achievements since Independence. I was in need of person who can do some of the other things for me. For example, design of back cover, front cover, reformatting, etc. So for this particular job, HBNI was kind enough to employ her as project assistant. She used to come here once in a while, but she was primarily working with me in Mod Lab. And this book cover, if you see, it is done so professionally. People tell me whenever they see this book that whom we hired for this, who was the designer? The designer was my own PhD student, Dr. Kruti Halankar. Then, of course, she went to Germany, University of Cologne, worked with one of my close friends, Sanjay Mathur. She spent about 1 year plus with him. Subsequently, she was in touch with me, of course, regularly. She got postdoc fellowship in US as well as this offer in Germany. Though I was convincing her that you go to US for postdoc, but she took her own decision, which I fully support and endorse. She thought now time has come that I switch over to industry. She has joined Mercedes-Benz, which is a global industry, and she is a leader in Mercedes-Benz. She, in the meantime, has become a globetrotter. I was told by her that she spends almost close to half time in different countries, and she leads a team there. Recently, she has filed 3 patents also. More formal welcome and will be done. Introduction will be done by Professor Datta, so I will not do further. Kruti, it's an absolute pleasure. When I realized that you are coming to India for a very short time, she landed yesterday only, yesterday evening, and today she came here despite jet lag, and she is leaving back for Germany on Jan 1st. So I'm really thankful that you spare time. And I once again welcome you on my own behalf and on behalf of all those who are present and on behalf of HBNI. Thanks for joining us.
Right, Dr. Kruti Alankar for presentation. I will give a brief introduction of her. Dr. Kruti Khalankar did her MSc from University of Mumbai in 2014 and completed her PhD from Baba Atomic Research Center, Mumbai, under guidance of Professor A.K. Tyagi, and in 2021. As Professor Tyagi told, that she also had another connection with HBNI. She did 4-month project work at HBNI after her PhD. Presently, she is R&D leader and lead scientist at Mercedes-Benz, Germany. She leads efforts on battery separators, a multifaceted area that demands collaboration across various fields, including chemistry for material development and stability, electrical engineering for insulation and ion transfer, mechanical engineering for structural integrity, material science for property analysis, manufacturing engineering for production process, safety engineering for preventing issues like thermal runaway, environmental science for sustainability considerations. Working on battery separators gives us the opportunity to collaborate not only with experts in engineering and basic sciences, but also with finance and purchasing teams. She is also recipient of CRS Young Scientist Award and SMC Emerging Scientist Award. So with this introduction, I will now invite Dr. Kruti Ahalankar to give her presentation titled My Professional Journey from a Research Lab to the Global Industry. So let us welcome her with a big applause.
I hand over the baton to Kruti.
Thank you very much for a very kind introduction. It was really, I don't have words actually after listening, because it is really a lot of respect that every time you come to India, I'm visiting colleges or I come here, Tyagi sir will always be like motivating and encouraging me to do little bit more, little bit more, little bit better. It's nice. It's nice to be. Okay. So, today I'm going to talk about my professional journey, how I moved from research lab to global industry, and how I'm going on charging myself like a battery. So, I hope that this talk would contribute at least to young minds and inspire them. It is my story. It is special for me, but everybody has their own special story. I would just be sharing some of my small experiences, and I would like to have better interaction. At my journey, I would like to say that before coming into research, there is something called passion or love for science that is very important to, you should have it at the early age. I don't have anyone doing scientific, like I don't have any scientific background as such in my family. So all I get is from my parents, of course, encouragement, and everything comes from school, beginning from school itself. My teachers, my principal, Sister Charlotte. So she was always there for me, listening to me, and saying that you have to be naughty, you know. If you're not naughty, you're not normal. So you have to be naughty and you have to be creative and you should be full of energy. So this is what I get from school. And my school teaches me to respect, you know, religion, all religion, everyone and everything. And this is very important when you step out of India, especially, you know. And this is what I get from my school, how to become creative and to be passionate and curious about what to do next, and uh, learn to face the big bad world outside. But it's not bad, so bad. Okay. So when I came to St. Xavier's College, it was life-changing experience because till that time, I was not talking to anyone. I used to go to school, come out of school, that's it. That was all it is. And all my friends, you can see, I'm still in touch with them. I'm still meeting them every time I come from Germany. I'm still like talking to them and it's still same. And they are the one, they used to say, Kruti, you are doing so well, so well. And I was like, no, I'm not doing so well. They are like, no, you are doing very well and you are going to do very well. So what is friendship? This is what I learned in St. Xavier's College. And my teachers, they enrolled us also for some civics responsibilities, like to go to some orphanage and teach in evening school. So you become very compassionate, you know, you become very, you start thinking about what is outside. You start becoming grateful of what you have. So this is very important lesson that I learned in when I was in Xavier's. And everything was spoon feeding, okay? Till that time, my teacher used to give me, I used to learn, and I used to vomit it in the paper. So it was very pampered and very nice and good life, I would say. When I stepped into my master's, it was very different. I was from University of Mumbai. I was given option to be in Satay College. Then, okay, in my master's for lectures, I used to go somewhere else and I used to do my practical somewhere else. So I was again doing in two different places. And so over here, I started understanding that nobody is going to give you everything. You have to search and you have to find things by yourself. So I became very responsible person. Satay College being like a very culturally, you know, close and traditional. So I became very religious actually. And I was like, okay, I can be that religious and I can be that spiritual. That is what actually was the biggest thing that happened in my life, you know, that was a changeover. And I fall in love with chemistry when I was in master's. So I didn't had any plans. I didn't had anything like I will do this, I will do this. I didn't had, I think most of the people like, I think here had planned, especially once most of them are from IIT Bombay or from HBNI or giving so big exams, etc. I was not like that. I was like normal. I think Rakesh sir also will relate much better. Rakesh sir, of course. So yeah, so it was normal. I started liking chemistry, and I will tell you that I was doing organic chemistry. So organic chemistry also like Tyagi sir, definitely. And I finished my MSc. You know, for my family, this was a very big doing BSc and MSc. Okay. So it was like a big achievement for them. But yeah, they never used to say that I'm doing well. They always used to say, okay, it's okay, you can do. Till date, I listen the same thing. And then Malushte sir, who was head of in Satay College, he offered me to become assistant professor at Satay College. And through him, I learned responsibility, doing time management, having better communication skill, being very particular about work, and having research interest. So he used to always tell me about his research stories, his PhD stories. Then, and I also used to listen to stories from my teachers in St. Xavier's College. And so that's how I realized my teachers used to say, you can do Kruti PhD. And I'm like, okay, if my teachers believe, then I should give it a try. So this is this is the way I came into doing PhD, you know. Okay, so now my target was, when I was assistant professor, my target was to do PhD because I was so influenced by my teachers. So first I gave my entrance in ICT Matunga. I gave interview and I felt that I'm not so good when I gave the interview. Okay, no problem. Then I thought I will go to University of Mumbai. It is like, now this is the thing that I should get, at least if I am good at research, I would say. And I was horribly rejected. I was not good at all. I felt that time that I'm not good for research. I thought that I'm really not okay. But my friend, so friends play a very important role, okay? Sometimes your parents cannot guide you. That is where friends play a very big role. So my friend told me, okay, there is interview for BRC in a month, so you can apply for it. And I thought, okay, I will try to give my best. And I am Tyagi sir was not there in interview, so maybe I got in there. I don't know. But when I was giving this interview, they knew everything and anything that I know about chemistry, I would say. So that was like the interview in which I was like, okay, they know everything that I know and I don't know. So I don't know now what is going to happen. And obviously I was rejected by so small, like, from places like, also from University of Mumbai. So it's not, I don't know, but I will give my best. I never get things easily. I have to try and I have to be like always energetic. That is what I knew by then. This is my mom used to tell me, that even for getting admission into nursery, we had to wait for 1 year. So you have to struggle, okay? So that's why I realized, okay, no problem. And then I got letter. Or is there any other procedure also? Then I came to BRC, all the formalities and everything. My God, such a big place I never dreamt about. I'm really grateful. And then I have 19 options on my plate. First thing, I'm not getting anything. And now I have like 19 options to choose which professor I want to go. And I was like, okay, so now what to do? I have only teachers for my guidance. I call all the teachers from Mumbai University and I ask them, okay, I have these options. They're like, don't tell me about option. We just know A.K. Tyagi. Professor A.K. Tyagi, that's it. And I'm like, okay, so there is nothing to do. And I was fortunate that I got opportunity to choose first. So first I had nothing and now I have to work with Professor A.K. Tyagi. I got information. Since I don't know many things, I am progressing slowly. I got information from my friends around DRC, like not friends, I would say people whom I came to know, that you will be working with Dr. Balaji Mandal. And then I was like, okay. And they told me that, Dr. Balaji Mandal is very good. Just do your PhD. And I was there with my doing PhD. And I would say I never dreamt in my life that I would be in such a good place. I would be, because of Balaji sir and Tyagi sir, I got opportunity to work in one of the premium place, that is IIT Bombay also. So I was working in IIT Bombay and BRC. So, and working with Amartya Mukhopadhyay sir, I am here first student for battery research. So working with Amartya Mukhopadhyay sir and his team, they used to give me wisdom where not to work and where not to waste time. And they were very encouraging and helpful to show me small paths. So yeah, it was I would say it was a nice, smooth, slow step journey for me. And what I learned over here was in my PhD, that is patience. Nothing comes, it comes with time. And from Tyagi sir, I learned that there is no substitution for hard work. So you have to do hard work. That's the only key to success. And Tyagi sir used to, and Balaji sir used to say, Kruti, you can do better. You can do little better every time. So now you got this paper, and some days you will get little more. We can do little slow. So these are the things that always kept me encouraging me and moving slowly. And that's how the journey of battery research began for me. Okay. So just getting, since the crowd is diverse, I would say that I would start my research by giving a short introduction. What is a battery? It is a storage device. We all have batteries. We cannot, we live, our life is tuned with battery technology these days, you know. We cannot think beyond it. So what is a battery technology? It is a transformation of chemical energy into electrical energy. Okay. And there are basic building blocks of this battery. You can see in the picture, there is cathode, anode, separator, and electrolyte. These are the main basic components of battery. And batteries can be like rechargeable battery. You can charge the battery, or they can be one-time use and throw batteries. So my work was basically associated with secondary batteries or rechargeable batteries. So if you can see in the picture, this I will not go into much detail about how I was making the battery, but this is just like a feeling how battery fabrication is done. I used to do at BRC. So you can see a layer of cathode, a separator, and anode sandwiched, and used to you can make a coin cell battery out of it. So this is how I used to make at BRC. And I used to learn battery fabrication, not only battery fabrication, but also how to make this cathode, how to make this anode, how you have to tune electrolyte, how you have to tune a separator, how you these are the small things, small basic understanding that I developed in BRC. Okay, so how is this battery working? Is that there is a transition metal oxide, which is used as cathode, from where the lithium moves through the electrolyte from the separator, and it moves towards anode. And this is how the charging process takes place. And then this lithium ion moves back to the transition metal oxide. And this is like a mechanism, lithium going inside, coming outside. So this is a charging, discharging mechanism that takes place. And this is called as a cell. When these many cells are combined together, it is known as battery. So this is what is battery. This is what is the understanding of battery. So very good question during my last talks. That is, what is a chemist doing in automotive industry? You know, what is the role of chemistry in automotive industry? So I would say that chemistry is very important subject. Actually, it is knowingly, unknowingly there in most of the fields, I would say. And you can see in the picture also that just by changing the different transition metals, you can have different potential range of materials. So those are anodes. On the yellow ones are anodes, and the purple ones are cathode, lithium metal oxide, lithium cobalt oxide, lithium iron phosphate. So all the transition lithium compounds are cathode. When you're combining them with different cathodes and different anodes, you get different potential difference. So depending on the application, you have to tune those things. So this is where the chemistry plays a very important role. I will tell you that when I started my work with lithium iron phosphate, which is very popular these days as a low cost cathode material, and it is popularly being used in electric vehicles. And another one is nickel manganese cobalt oxide, which has been popularly used by premium range electric vehicles. It is because it is having a higher potential range, and that's why it is used in premium range. So this is my favorite paper. This is where my journey begins. It was like when I started this work, I would say that Tyagi sir and Balaji sir told me that let's start with a very known compound. So this known compound, and understand and investigate it and learn what is a battery technology. And in spite of being a very known compound, it was a very nice idea that came into account, that in many papers, people used to report that lithium iron phosphate is always formed with lots of impurities. So Balaji sir suggested me that during his postdoc also he observed a similar thing. So let's tune on the ion precursor. Let's increase just a basic understanding that at higher temperature, when you are heating the compound, there is a possibility that lithium precursor will sublime. So what we did was we tuned this lithium iron phosphate by adding different proportion of lithium precursor. And I will tell you that during this project, I learned what is a cathode material. I got exposed to understanding different analytical tools which I had never handled previously, like XRD, Raman spectroscopy, SEM, TEM, CHNS analysis, MOSBA spectroscopy, and it is still, I would say, it is a very good opportunity when you're working at BRC that you can have exposure to very high-end technologies, and you can explore and learn many things. So this is how I could do. So I got understanding to MOSBA spectroscopy, proton-induced gamma emission, which I have seen that in Germany also it is very difficult, to get experience of it or to get this done. Though it was a very time-consuming process, you would say that in BRC it takes a lot of time. I would say that it is similarly, equally difficult to get things done everywhere. It is challenging. Nothing is whatever you have, you should be like saying that, okay, we figure out ways. It is everything. In Germany also, there is a lot of bureaucracy. Things take time. So it is same in BRC, I would say. So if you want to get things done, you have to be patient. And so after tuning on lithium precursors, we understood through MOSBA spectroscopy that after addition of 5% of more precursor, the lithium iron phosphate as cathode material would be performing much better, would be giving much better capacity, which which can be tuned to much adverse condition and can be used at a best performance itself by adding extra 5% of precursor. Okay, so another example I would give of anode material, that is MOS2. So I would like to say that when I was in BRC, I got to learn different synthesis methods. Being working in solid state chemistry group, I got to learn like sol gel method, solid state method, then hydrothermal synthesis method. So it is very important for a material scientist to have exposure and understanding to different synthesis route. So this was the first learning that was very important, that is still very important for me in industry to understand. So here also we did hydrothermal synthesis, we did electrochemistry, I learned to make coin cell batteries with material synthesis, and most important thing is that in this work we did in situ doing exams measurement in RRCAD. And I would tell you that this was a very different experience, because with the Bendu Bhattacharya sir's group, I was able to participating in designing of this battery in which you can do in situ measurements. And this was the first battery that was prepared and to do in situ measurements to understand the mechanism of the battery. Now, move to my postdoctoral research, and I would like to say that having exposure in BRC, being Tyagi sir student, I got opportunity to go to Germany and do my postdoc in University of Cologne under Professor Sanjay Madhu. So when you go abroad, I was always in Mumbai. I was always living with my parents. And so it was extremely difficult when you go abroad suddenly. So I had to learn one thing, that is adapting with the culture, with the people around, and having cross-cultural communication, respecting and appreciating Like, like you need to be grateful, like what you provide. Parents are there to observe you, to provide you. When you are alone in abroad, you have to be very alert, you have to be and you learn to appreciate whatever you have in your past. So when I was in abroad, I got to know different fellowship that I could have applied when I was in masters, when I was in PhD, which I couldn't apply, I was not aware. But so whenever I get any opportunity to interact with student, I have like list of fellowships. I always send them. So I have missed, maybe it helps someone else. So I always have a nice email prepared with all the fellowship and all the details. And I want to reach out as many students as possible to give this information. So when I was in Cologne, I got an opportunity to write Dad Vice Fellowship proposal. And through this, I got one student from IIT Kanpur. And it was very nice experience being in abroad, having having a student who is so energetic. In bachelor only, he's coming to do his Dead White Fellowship and doing his completing his experience in Germany. It was quite inspiring for me, and I'm very happy that he is now doing directly his PhD after bachelor's in Stanford University. So it's very nice. It's good that if anyone wants any of such information, I can definitely provide. I can definitely help out. One of the important thing that I also would like to say, that being in Cologne, I got opportunity to become diversity officer for American Ceramics Society. So I got opportunity to go to America and get exposure how work is done in America, also how different it is from Europe. So that's what I would say. And how to become a sustainably developed lab, how to have goals of sustainable development in yourself when you are working in laboratory. This is what I learned, and it is very important. So throughout my battery research, I would say that since I was in BRC, I could learn to do different synthesis of different materials. Since I was first student for battery research, I got opportunity to learn how to build up a battery lab, for which I would say Balaji sir was always there around to ensure that everything goes well, and Tyagi sir for all the documentation. And it went good. I learned a lot through this process, how administration also works, that is also important. Then with this, after doing this, I learned to do fabrication of battery, how to do electrochemical analysis, how to investigate, how to test batteries. And I was also working on, to certain extent, in next generation batteries, to certain extent like in solid state batteries, in lithium sulfur batteries. I was aware of and I worked a lot in sodium ion batteries. So I was quite encouraged to learn a lot in BRC. I was given freedom to explore different areas, I would say, and that was very good. I also got opportunity to do in situ, ex situ, that is post-mortem analysis of the battery. Then when I was in postdoctoral research, I was exploring how to do recycling of batteries, how to make batteries reusable, to use, make, remove, to like to decrimp it and try to use the electrodes again and to build batteries again. And when I was presenting last year at BRC, I was saying that I'm working, I have moved from lab scale and I'm working in pilot line scale. And I never thought that I would jump it into production within a year of span. And now I have just touched and I'm entering in with speedy entry into production also. So it's very different experience. How different it is also, I will give some examples. First, when I got in global industry, when I was working in industry, I would say I got opportunity first directly into industry, but I'm doing right now also, I'm working with students, with master student, to get some research topics which are production point of view very important, very small topics. And we try to investigate the basic root cause of all these problems that are arising in manufacturing and production. And it is very interesting to know and investigate deeply even a smallest problem, And so in this case, when I'm working at automotive cells and working with Mercedes, I get opportunity to work with RPTU University, with Karlsruhe Institute of Technology, with ZSW, which is also in Karlsruhe, with Hochschule Kaiserslautern, and Landshut University also now. I have not had it. So all these universities, I have few students working around, and that keeps me integrated to lab activities also, to be very close to research activities. And in Germany, I am developing innovative laboratory for innovative research, wherein I'm building a lab. I have recently completed building a lab for coin cell fabrication. And now I'm speedily working on SLP, like single layer pouch cell, multi-layer pouch cell. So I'm investing a lot of time when I'm in Germany in building up the laboratory. If I would have been cribbing during my, oh, I have to build up laboratory, then I would have never been able to do this, when I am in industry, I would have never been able to do. And I will tell you that the bureaucracy that we have at BARC, still we have the similar things in abroad also. You have to go through them. Things take time. It doesn't happen quickly. You have to be patient. So I would say that it is a nice experience, but since I learned it earlier, it was easier and it was faster for me to select, within one day I have to select. I know which instrument has what problem. I have worked and it was good for me. Then my step 2 was getting more close to battery separators. So in order to understand more on battery separators, I need to understand what is cathode. I need to understand what is anode. I need to understand what is electrolyte. What is the behavior of these three components? And since I had learned and I had studied them thoroughly during my PhD, it was a little bit easier. And I will tell you what is, when you talk about separator, most of the people have an idea. Oh, it is just a plastic material which is kept inside the, which is placed inside the battery, and that's it. It has no performance-oriented issue. It is not a performance-oriented material. It is just a plastic thing that is kept in between the cathode and anode. I would say that I got opportunity to say that it is not just a material, it is a performance-oriented material, and it needs to be given a lot of attention. So I would say that I started working on separator also at very early stage in the company also. So I had to prove that how important it is. Being from basic sciences, having known about all the roots, it was easier for me to convince things and to make things like budgets also available for separators. So you can see on the right corner that separators, they are just roll and they are just white material. They come in roll. They are usually provided in such way from the suppliers. And I will tell you that depending on the chemistry that you select, whatever chemistry it is, like maybe lithium iron phosphate, maybe nickel manganese cobalt oxide, maybe lithium cobalt oxide, the chemistry, the structure of the separator changes. The behavior of the separator changes. So this is where I am understanding how the behavior of separator is in different chemistry. So the separator is just a base material. It is a skeleton which may be made up of polyethylene materials, polypropylene material, okay? And on top of, so this material is highly porous. It gives mechanical strength to the material. And all the mechanical properties usually come from this material, base film. So the selection of this base film is very, very important. Very, very, very crucial step. One. Second thing is that you need to give thermal stability to the material, to the separator. And that is when you need to coat it with ceramic layer. Ceramic layer also can be bromide. It can be aluminum oxide. It also has different behavior with different cathode and anode materials. So you need to understand with aging, how will it behave? How will it interact with the material? So that is what understanding. Understanding cathode and anode is very, very easy. It is happening on the surface. It is changing the molecules and degrading the compound. It is very, very easy. But understanding separator, and also it is a white material, you cannot do SEM also. It's very, very difficult, to sometimes analyze what is happening on the separator. And then this ceramic layer can have different, and if you choose a wrong recipe, the ceramic layer will be very fragile, and lots of reports that have been reported in past decades are due to thermal runaway, that is exploding of battery. So if you choose a wrong battery separator, then you are going to have lots of safety issues. So this is where the chemistry is involved. This is where understanding of this ceramic layer, the recipe, is very, very important. Then on top of it also, you can have another polymer material which is coated on top of it to make the production stable, because to give some I would say, to give good integrity, good adhesion to the cathode and anode material, so that the production is smooth. So depending on what polymers you are coating, also the chemistry changes. So, and how much amount, how much thing, how much amount will have what impact on the mechanical properties of the base film. So it's beautiful. It's amazing to understand all this behavior in detail. So first thing is that you need to understand the structure of which separator you have to choose for which chemistry. That is what I mentioned. It because porosity, pore structure, connectivity, permeability, all these impacts, all these factors are directly impacted. Then on the basis of what kind of materials you are coating, it will have direct impact on the thermal mechanical. So you need to have lots of information of mechanical engineering. You need to have a lot of information of thermal engineering. This is very, very important. And then you need electrochemistry. And so all these three, you need to be expert in all these three areas in order to have a good expertise on separator. The battery that is shown, the coin cell battery that is shown, it was this coin cell battery which I was doing when I was doing my research in BRC. I used to prepare this size of coin cell batteries, and you can see on the right hand side the battery that are being made. They are like a stacks. This is like 1/40th size of the battery that I am working currently. So it is as more bigger than me, I would say. So and so yeah, so it's very different, like small like coin cell which I can just hold like that, and now I cannot hold them. So it's a very different experience, and working inside the dry room without, like, not even your eyes, nothing is exposed, and continuously working in that kind of environment is amazing. It's amazing because what you're doing in lab, if you when I saw the battery for the first time, this battery, I was like, wow, I'm working on something inside this battery, and it makes me feel so good. So when I was doing this activity, I realized the activity stops over here. Okay, I'm having a good chemistry understanding to the separator, and it is being used in lamination. Then I was given a topic. Okay, figure out what is the lamination parameters. How do you do the process of this separator? Okay, so now I will tell you that right now, before going into this topic, when I was I was getting an understanding about myself that I cannot be a good leader, maybe because it is very difficult that you are coming from different cultural background to lead in international lab or international world. It is very, very difficult. So I had some self-doubts, and I thought that maybe not. I don't know. So I will tell you, my first step was becoming a battery scientist, which I could achieve to certain extent in BRC itself, with very good knowledge on material science and analytical tools to use. Definitely, I'm still learning lots of analytical techniques now also. And my second step was, I mentioned, with advanced engineering, exploring new patents, understanding different technologies. That was my second step when I was in global industry. And my third step, I would say, mechanical engineering. I am surrounded by lots of mechanical engineers at home also and outside also, because I will call my brother. I do not understand this mechanical problem. Come on, you are a mechanical engineer. Answer me. So he's like, no, I cannot know everything. Preparing PFMEA, DFMEA, design failure models. Oh my God. First, I have to understand this theory. At night, I'm understanding these theories. Because separator is a multifaceted area which gives me opportunity to collaborate with different types, different engineers and different teams to understand more and more in detail. So with mechanical engineers, it is very good. Then comes with process engineer. I have very good friends, but when we are doing some technical things, we have like, no, you cannot do that with my separator. Okay, I have to tell them to process. You are impacting it. You are impacting you will degrade my separator. Being a chemist, I know it. I understand it. So then I am working with process engineer. I study process, so answer them much better. For this, I would say students who are working in research lab, they help me a lot, because they're doing like a lot of small process related experiments, a lot of small mechanical engineering related experiments, and that gives me a lot of information and understanding towards the subject. Then I would say that I'm working with quality engineering. So immediately there will be a call that, okay, so in technical specification, these are the things that are there. What is your lookout if there is change in this parameter, if there is a change in shrinkage of the separator, what do you have to say about it? So you have to be good in understanding and responding to quality engineering. Then safe V&V team, that is validation team, one of the important branches, safety aspect, like maybe like nail penetration, thermal runaway, all these things. You need to understand. All these reports comes on my desk. I have to read them. I have to understand it. And so I have to study. I have to study. There is no way. Being a chemist, take that background, understand this, work on it. Anytime you can have problem in production and manufacturing, you have to answer on the spot. You have to be that smart enough. So this doesn't, I'm not expert, in all engineerings, but this I need to know. I work on it, I understand it, I learn it, and then I'm facing it, and I'm becoming more and more confident each day. Electrical testing, electrical engineering, then CSR, corporate social responsibility. So you need to be aware of this also. When you're changing a component in anything, how much CO2 emission is occurring. So you have to be aware of these things also. Whenever you're making any technical change, you have to talk to the suppliers constantly. What is happening? What is trending in market? Then according to that, you have to work with finance and purchasing and make them understand you need this, how to get it done. So you have to participate in those meetings also in order to ensure all the problems and to find a solution. So this is a broad working style that I have in industry, and it is good that I get opportunity to collaborate and advance in understanding of performance, safety, and environmental impact of the battery. Okay, then the milestones that I have: BRC, having a PhD degree, biggest achievement. I tried to find out photo in which almost everyone is there. So that Rakesh sir, Balaji sir, Sadhika ma'am, Acharya sir, everybody is there. I think this is the first year PhD photo. So yeah, I tried to. I am very, very thankful to everyone because each and every person has taught me many things, not only science, but also life. So it's very important. And I'm very fortunate that I have experience that I have worked in IIT Bombay and HBNI also. So it's nice to have such a beautiful name of universities on your CV always. Then also when I was in postdoc, I learned different culture. I learned to interact with different nationalities. You can see this is a picture of Carnival Festival, and unknowingly I selected also working. This was not intentional; it was unknowingly, and I think unknowingly you planned up what you are thinking deep down. So hard work, sincerity is very important. I am not very intelligent or exceptionally very good, but yeah, I was doing small step every time. Then very big achievement for me was getting emerging scientist award, SMC emerging scientist award, and also young scientist award. And this was thankful to Professor AK Tyagi that I could get such big achievements. And this is how I'm working from laboratory scale, pilot line scale, manufacturing, entered now in production. And I feel very, very energetic and motivated to do more and more, learn more and more. Thing in the picture you can see on the right side is my R&D team, R&D, my colleagues with whom I'm working, and it's amazing. They are awesome. It's very different way of working. You need to learn, and then it's awesome. Other things, I think that most of you would like to know what is the difference between the work culture between working in India and working in abroad. So working in India, if I wouldn't have done my PhD in India, I don't think so I would have been so good. Like I would have been so much better. I am not best, but better, little better, because being in India, you learn to do many things and you try to figure out things if it is not working. And that is very, very important for you to learn. And I would say that I was fortunate that I had a very good supervisors, and so I could work smoothly and calmly during my PhD. And I was not just doing PhD, I was doing other activities also. I used to go like work with different DA teams to do some plays or go for 15th August or 26th January. Yeah, singing also. So I was not just, I never did only one thing. During during BSc also, I told that I was working in orphanage. So I was never like just working and doing things. And now also I'm not just working. I'm doing many other things, and I'm like enjoying and working and keeping myself motivated. This is also important. Living life is also very, very important with your career, I would say. Yeah, lots of paper published during my PhD with Tyagi sir and Balaji sir. Really, they have worked a lot on me to achieve so many papers, I would say. Then I'm really thankful to Tyagi sir, Balaji sir, Dibyendu Bhattacharya sir, because through him I understood the physics point of batteries, and Amartya Mukhopadhyay sir to give me opportunity and his willingness to work in his laboratory, and all the collaborators, everyone whom I have worked. I'm thankful because I've learned many things from each one of them. God, friends, without them also it's not possible, and family, very, very important. So I begin my journey with dhanyavad. When I'm in different countries, I'm usually saying thank you, because it's not difficult. It's very difficult to learn many languages. Then in Germany, vielen Dank. Then bitteschön, yeah. And when I'm in France, merci. So just crossing the boundary from Germany to France also, there is very different work culture. There is very different work ethics, and it's beautiful to learn and understand different culture and having international friends. And I'm very helpful that I still have very good supervisors who are supervisors, I would say, because I'm still learning and having good understanding, like Dr. Christoph Weber, who is in Germany, who is director, always there for me to help me out. Then Antoine, who is French, he is also there. But there is always way to learn. You can do it. Let's start. So it's good to have someone like this to be encouraging always. So I would like to thank everyone for patiently listening to me.
Thank you, Kriti, for such a wonderful presentation. There may be some questions from offline.
German language, he says.
Okay, so that's a very good question. For me, German, being in research area, German language is not mandatory. And in my company, if I'm not mistaken, there are almost 60 nationalities. So we are talking most of the time always in English, actually. And regarding German language, I interact with people and I learn. I'm still learning. Small step, very small. Yeah. So batteries is a field that is still developing. It is still under research as R&D. It is still under research. So lots of things have to be worked on. And if you see companies like LG, big companies like BYD in China, many reports decade ago were reported by them also when they were in the research phase. So it is obvious that this can happen because it is in under research stage and it will improve with time. It will.
One thing I may add, when 10 years back, there were a lot of incidences of battery explosion all over India. Those particular lot of batteries had some sealant issues. So that was and they were withdrawn also. All the batteries were withdrawn. So there are multiple reasons. Sealant failure is one.
The capacitors is slightly different from that of batteries, and overcoming it won't be, I would look it like a hybrid topic. I personally think it can be a hybrid topic.
I may further add, as he says, that power density and energy density, you have to optimize the both. So supercapacitors are on top of the y-axis and batteries on x-axis. Power density, energy density. So your answer is correct. By hybrid approach, you have best of both. A lot of research is underway to push supercapacitors towards right and batteries towards top.
This is a very good question, and I would say that I work with some suppliers from Korea and China, and they are very good at it. They are recycling the material and they're doing it exceptionally very well, and we have to learn from them. seen that in Korea it is more. I would say it is advanced. Everybody is working on it. Experienced. Yeah. This is this is a research topic, I would say, and so it is going on. And I have seen many small scale work is small scale industries, like for example mobile batteries and everything. On a smaller scale it is possible and they are trying to do it. On a larger scale it is still a question mark. It is still on the way to work.
See, there are two things. I think I will respond, being your guide. See, one thing is that repairing of battery, changing something or the other. But for battery, a day comes when it loses its active mass. The active mass, once it is lost below it, or it is lost for side reactions, or it is below the optimum amount, then one has to go for recycling. You cannot generate active mass. Suppose LiFePO4 or LiCOO2, they lose lithium because of side reactions, and those products are not conducting lithium ion. So lithium is locked in those products and which can't be utilized. You can't intercalate, deintercalate, which is required for charging, discharging. So when battery comes to that stage, in that case, the only option is recycling. You have to open it, post-mortem, you have to open, dissolve, and separate the lithium ion. Most important ion is lithium. Cobalt also. India doesn't have cobalt ores, for example. Very little cobalt is there. And you were right, or maybe she was right, one of you. South Korea definitely has got very advanced recycling for everything, because South Korea is a country which does not have much sources of any valuable elements, leave alone critical elements. Even normal elements also they don't have. They recycle entire aluminum. And I will further add, if you recycle aluminum and put for reuse, that is 1/3 as costly as getting new aluminum from bauxite. So that's what I thought I would like to answer.
Yeah, that's why we are working on blade cells, like long cells, thinner batteries. Long cells and thin.
For femtosecond lasers are used for fabrication. You are right. You are right. You are absolutely right. Because they can deposit a lot of power very precisely. Pulse width is so narrow.
But I would say that in industry, we are not looking more into very close to research oriented problem, which are under developing stage. We are working on this, on the topics which are very widely developed and making it available for manufacturing and production. So there are many such n number of research going on, like nuclear batteries also, everything. So,
there are two questions online from Vishwa Teja.
yeah, so it's a very nice question. Whenever I start my process related questions, first thing I go to computer engineers. I work with them. I tell them that suppose I'm having these conditions, what is the time required? What is the temperature required? They work for me. Then I reduce my experiments. Otherwise, there are lots of probability. And for this, computational work, engineers play a very important role. The first thing we go is to the computational engineer, I would say.
Sodium ion battery.
Sodium ion battery, very I have worked a lot in sodium-ion battery, and for India, I would say sodium-ion battery. If we become experts in sodium-ion battery, it will be a biggest achievement for us, and definitely we should not one thing I would like to say that when sodium-ion battery was explored, similar time lithium-ion battery and sodium-ion battery were explored, but lithium being smaller in size, it was encouraged and it was motivated to do lots of research, and that's the reason sodium-ion was left behind. But still, equal amount of effort, if it is put in sodium-ion battery, it has lots of potential to be used in EV batteries.
And Vishwa, you are right that lithium has got low abundance. Not only low abundance, its geographical distribution also is highly skewed. Lithium predominantly is found in ABC countries: Argentina, Bolivia, and Chile. China has some lithium. So these are the problem. Abundance is about 20 ppm, if I remember correctly. Sodium abundance is 20,000 ppm, 20,000 plus. And lot of work, as Kruti answered, lot of work is going on in BRC also. Our colleague Dr. Dimple Datta herself has done a lot of work. Sometime you come to BRC, or if you are already in BRC, I will introduce you to her, so you can learn more. So work is going on not only abroad but in India as well, from China. If we plug in continuously after fully charged, what will happen?
So when we design a battery, we always consider that there will be some customer who will be overcharging the battery. Okay, so this protection circuit is already inside battery to certain extent. So it is being considered when you are developing a battery.
Yeah, that's correct. Now modern batteries, modern cell phones have got this safety, so it will stop the feeding of current here once it reaches 95%. But person like me who has bought only 3 phones in his life here, each phone I have used for 6 to 7, 8 years. So my phone may not have this facility. It is there. But his question is, what happens if suppose this protection is not there and someone overcharges? Many things can happen. But one thing which most commonly happens is formation of lithium dendrimers. And they are very unhealthy for batteries like the lithium dendrimers may cause short circuiting also. So never overcharge. Though I do myself most of the time. Till it becomes 100, I will not take it out. And from 90 to 100, yeah. From 90 to 100, it takes 2-3 hours.
Yeah, you don't have to worry because there are, electrodes in batteries. One is for cathode, another is for anode, and third one is for temperature. Basically, that is temperature sensor. Once it sees the temperature is going up, it will disconnect the circuit. So nothing will happen.
It's an inspirational talk. I'm having it.
So, hi Kruti, wonderful talk. I was wondering whether you could explain how you applied for the job. What was the process? Was there multiple interview rounds? So was it direct selection? Also, if someone doing PhD in fields not relevant to industry for transition, what should they do? Kruti, you are the best person to answer this.
You can also write me if you have many questions such a way.
This can be
But I can just say that when I was doing my postdoc, I thought that I would try all the options. I was open to all the options, and I was flexible. That is very important. When you do PhD, you should be like a little bit flexible also. And I got several postdoctoral opportunities, and I got industrial position. My friends, I chose Karlsruhe Institute of Technology to go with my further postdoctoral research. My friend told me, ask yourself deep down, what do you think? What will you think after a few months or after pursuing this postdoctoral research? And if you'll miss this opportunity, what will you think about it? I would think that, oh, I should have at least tried and see if it is working or not. Then he's like, you are outside India. You have all the freedom that is given to you, that you can experiment on yourself and explore. You will always, if you got now, you will always get in future also. And I thought, yeah, that is right. I asked myself that should I give this a try, and that's why I landed in industry. And in abroad, I have observed that till the time you are not matching perfectly to the profile, you will not get the opportunity. And for me, when I'm working, I feel that, oh, this position is just made, just tuned for me. And the I would say, when I was applying, I was just applying. I was flexible. I was applying through LinkedIn, and there were lots of rounds, technical, personality check, etc., lots of round for all the interviews. But once they call you for interviews, is usually that they know that you are a candidate, you are having technical knowledge. So more than technical knowledge, they actually check your personality and how well you can integrate with their system. That is very important for Germans. They don't want to have a person who don't want to work with them.
And one more thing I may say here, when Kruti got postdoc fellowship in Karlsruhe, University of Stanford, etc., she was consulting me regularly and this industry. So I, being a academician for last 40 years, I was trying to convince her, you go for postdoc, come back, join some good institution for IIT, etc. So I was pressurizing her or convincing her, not pressurizing, to go for Stanford, because it's a such a wonderful and top class university in the world. So Kruti is, she took her own decision. I could not brainwash, and she took her own decision and decided to join Mercedes-Benz. After joining, on day one, she called me to break the news that she has joined industry. And what decision you have taken? I mean, I always say one should do what your heart says. As simple as that.
Yeah, and I would say I have a very sweet brother who is always saying me, give it a try. If you don't try, if you fail, I am still there. Don't worry. I am still there to support you. Even if there is any issues, it's fine. Just give it a try. It's very important. Though he's younger, he gives a lot of explanation to me.
Thanks a lot, Kruti.
I have one question. What about the future for this AI? I think everywhere the role of AI is tremendous. In the field of batteries, what do you think that the role of AI, artificial intelligence?
Artificial intelligence, as such, we are not doing any exploration in that area, or I am not aware of it, either of it.
One of the person from Pacific National Lab, Mr. Vijay Murugesan, I think you know that.
Yeah, I am personally not working with artificial intelligence, but it will definitely have scope in battery technology. It will have scope in every field, I would say.
Yes, but to give a precise answer, AI is going to play a very important role. There is a concept called as data mining. So from periodic table, AI is going to have data for each and every element, all the 108 elements, and then AI will tell you this is the best compound for given property.
So through the play, I think they have developed a material also.
Find substitute for LiCO2, LiFePO4, etc. So AI is going to play a role, but I always believe more than computation, you should believe on intuition also. Intuition is superior than anything else. Gut feeling.
And then my I understand, but management wants data.
Yeah, I have one question for you. You've talked about safety and all those aspects. How about the pricing? Because in the EV vehicle, like electric vehicles, the biggest part of the money that we pay is for the battery. So when is the pricing coming down?
It is significantly coming down, actually, I would say. It is significantly coming down, and it will drop further in a decade span, I would say.
Comparison can be drawn with the cost of per unit cost of solar. It crashed. Recently, we used to say a couple of years ago, we used to say it is 18 rupees per unit, 12 rupees, now 2.5 rupees. So what she's correct with time. And once sodium and batteries become competitive, then absolutely sodium is equally abundant all over the world. World is costly.
We got the lithium iron.
Yeah.
So cost is also going down. Now, more and more exploration is this mining and all these things are going on. So that's
So cost is going to decrease only.
Because actually we are still
reusability. Yeah, once these are bad, then one can open it and then reuse. Because everybody, we all have a mobile. So we all have another battery with us. If we recycle and if 90% you can recover, basically 90% of the battery we have already.
And even in 60s, 70s when I was growing up, maybe before that also, in India, all over India, we had mechanism of collecting newspapers. Like this, we should have mechanism for collecting at point of use.
Yes.
If someone can come to your house, my house, is any used batteries there, I will pay 10 rupees, 20 rupees, 50 rupees, whatever.
Yes.
Monetize.
Yes.
He will monetize it.
Urban mining.
Urban mining. And then he will sell in much more price. This kind of mechanism is possible. Point of use collection is required. You cannot say put in the so and so box, somebody then, green box is made for, I think, e-waste only. But how many people are putting? I have my own doubts there. Large number of people don't put also.
Yeah, maybe
So
some
best is for have point of use collection. When 50 years back, it could be done for newspapers. Why not for your plastic bags for milk, for example, or used batteries, used CFL? It should be done. It will be done definitely. Point of use. Yeah. Not central.
and reusing. So I would say that earlier when there were mobile phones, in market, they were very, very expensive. Nobody used to have mobile phone. It was a luxury, and now everybody has it. So with time, it has exponentially, the cost of batteries was exponentially decreased for mobile phone once the research activity was matured. And for EV, the research activity is still maturing, and therefore lots of funds has to be invested in research activities, and therefore EV become expensive. Once you tuned on this process, the market will, the price will decrease. And I also would say that if there is also plan B that is happening, that is, if you are not able to recycle in much better efficiency, in that case, after certain life cycle of the battery, they will be collected by the EV provider industry, and they will work on that particular lifespan to make it reusable by doing some research.
Such kind of things are available where they say after a certain usage will collect the battery.
Collecting. Yeah.
But whenever I have gone to the market and inquired about the price, the major bulk of the price is for the battery. Yes, for the battery.
Yes.
And now I would request Professor A.K. Tyagi to present the speaker with a small plant as a token of our appreciation.
I don't think that the positive for SPNI. Again, please occupy your place.
I request Professor P.C. Selvin, Registrar HBNI, to give the vote of thanks.
So what are you going to present here? First of all, it is an immense duty to thank Dr. Kruti Kalankar from Mercedes-Benz, Germany. I think she has given a very motivational, inspirational, and natural way of talk, motivating all the students, starting from her passion for science. And she has admitted very clearly that because of the motivation of her teachers, she has reached to this level. And the way in which she explained all the things was very, very natural and highly inspirational. But I think it is motivating every student that they can achieve this one. With a great quote, you mentioned that always there is a way to learn. Whatever it may be the situation, and you have explained that not of big achievements is needed. Only basic thing is what you have to have the mindset to reach this height. Yes, there is always a way to learn. So I thank Professor Tyagi to introduce her, and Professor Datta, the convener of the program, for making this event a grand success. And I thank all the scientific officers from DAE and faculty members of HBNI, especially students, for taking part in this program. Thank you all. Jai Hind.